In this session, we will take a look at remainder theorem. What kind of questions are solved by remainder theorem? Let us take a very simple example of one question that can be easily solved by remainder theorem. Suppose the question is, what is the remainder when 22 into 23 is divided by 7? The first thing that I would like you to do is identify with the traditional method of solving this question. What would you do to solve this question normally? The first thing is, you would multiply 22 and 23 and then divide whatever the product is by 7 and calculate the remainder. But this method is efficient only for smaller numbers. If the number 22 and 23 were replaced with larger numbers, or if there were more number of numbers, this method is simply not good enough, or it is not quick enough, and therefore remainder theorem is required to solve such questions. So what is remainder theorem? Let's see one example to understand remainder theorem. What is the remainder when 22 into 23 is divided by 7? When 22 into 23 is divided by 7, the first thing you need to do is divide 22 itself by 7, which can be done orally. So 22 divided by 7 yields a remainder of 1. The next thing is divide 23 by 7, which yields a remainder of 2. And the third step is, instead of multiplying the numbers 22 and 23, simply multiply the remainders. The remainders in this case are 1 into 2. So the final remainder when 22 into 23 is divided by 7 will be equal to 2. So this simple theorem is known as remainder theorem. So let us look at what remainder theorem is. If we have a number n1, which when divided by another number p yields a remainder of r1, and if we have another number n2, which when divided by the same number p yields a remainder of r2, and a third number n3, which when divided by p yields a remainder of r3. Then if we want to find out the remainder when n1 into n2 into n3 is divided by p, we need not multiply n1, n2 and n3. All we need to do is multiply the remainders that we have obtained previously. So remainder when we divided n1 by p is r1 into when n2 was divided by p, the remainder is r2 into r3. So when n1 into n2 into n3 is divided by p, the remainder is r1 into r2 into r3. Similarly, when n1 plus n2 plus n3 is divided by p, the remainder will be r1 plus r2 plus r3. This is the statement of remainder theorem. Let us solve one more question based on this. What is the remainder when 181 into 183 into 187 into 189 is divided by 12? So again, the remainder when 181 is divided by 12 is equal to 1. Remainder when 183 is divided by 12 is equal to 3. Remainder when 187 is divided by 12 is equal to 7. And remainder when 189 is divided by 12 is 9. Overall remainder will be the product of 1 into 3 into 7 into 9, which is equal to 189. But as you all know, 189 is greater than 12, and therefore we divide 189 once again by 12 to obtain a remainder equal to 9. So final remainder when 181 into 183 into 187 into 189 is divided by 12 is equal to 9. These questions were easy. How to calculate the remainder when numbers are bigger powers of a smaller number? Let's take an example. What is the remainder when 14 to the power of 73 is divided by 11? Will remainder theorem work now? Obviously it will work, but solving this question by remainder theorem alone would be a time-consuming and tedious task. So we'll have to make some adjustments, and adjustment in the form of identifying patterns. So let us try to solve this question. What is the remainder when 14 to the power of 143 is divided by 11? Obviously, the first thing that we need to do is 14 to the power of 143 when divided by 11 will have the same remainder as 3 to the power of 143 divided by 11. But calculating 3 to the power of 143 itself would be very tedious. So we try to see if there is a pattern for remainders. And there has to be a pattern, because if any number is divided by 11, the remainder can be at most 10 and at least 1, right? So let us see what happens. When 14 to the power of 1 is divided by 11, the remainder is 3. 14 square divided by 11 yields a remainder of 9. 14 cube divided by 11 yields a remainder of 5. 14 to the power of 4 divided by 11 yields a remainder of 4. 14 to the power of 5 when divided by 11 yields a remainder of 1. 14 to the power of 6 divided by 11 gives us a remainder of 3, which is the same as remainder of 14 to the power of 1 when divided by 11. So we see that this pattern will repeat now, and the pattern will repeat after every 5 terms. Let us first of all see how we obtained this pattern. 14 to the power of 1 divided by 11, we obtain a remainder 3. This is simple. To find out the remainder of 14 square, we write 14 square as 14 into 14, and instead of multiplying it to get 196, and instead of dividing 196 by 11, what we do is we apply remainder theorem. So what is the remainder when 14 is divided by 11? The remainder is 3. What is the remainder when the other 14 is divided by 11? Again, the remainder is 3. 3 into 3 gives us a 9 once again. This implies that 14 square when divided by 11 will give us a remainder of 9. In the next stage, we are required to find the remainder when 14 cube is divided by 11. So we break 14 cube as 14 square into 14. What is the remainder when 14 square is divided by 11? We just obtained that. The remainder is 9. What is the remainder when 14 is divided by 11? The remainder is 3. 9 3s are 27. 27 is larger than 11. So again divide 27 by 11. And we obtain a remainder of 5. So 14 cube when divided by 11 gives us a remainder of 5. The next stage is to find the remainder when 14 to the power of 4 is divided by 11. 14 to the power of 4 can be broken as 14 cube into 14 or 14 square into 14 as we have done here. So 14 square, what is the remainder when 14 square is divided by 11? We have already found the remainder as 9. What is the remainder when next 14 square is divided by 11? Again, the remainder is 9. What is the final remainder? The final remainder when 14 to the power of 4 is divided by 11 is equal to 81. 81 divided by 11 again, and when we divide 81 by 11 again, we obtain a remainder of 4. Next, 14 to the power 5 can be broken as 14 cube into 14 square. We could also break it as 14 to the power of 4 into 14. Either ways, we will get the same remainder. 14 cube, we have just found the remainder. When divided by 11 yields a remainder of 5. 14 square when divided by 11 gives us a remainder of 9. 5 into 9 is 45, which on being divided by 11 gives us a remainder of 1. Now remember, whenever we are calculating remainders of different powers of a number, the moment we obtain 1 in the sequence of remainder, you assume that for the next power, the remainder is going to repeat. In this case, 14 to the power of 5 divided by 11 obtained a remainder of 1. So from 14 to the power of 6, the remainder is going to start to repeat. So for 14 to the power of 6, the remainder is the same as the remainder for 14 to the power of 1, which implies that pattern of remainders repeats after every 5 terms. Now we can utilize this information to answer our question. But first we generalize. When 14 to the power of 5k is divided by 11, the remainder has to be 1. 5k is any multiple of 5. So 14 to the power of any multiple of 5 when divided by 11 gives a remainder of 1. 14 to the power of 5k plus 1 when divided by 11 gives a remainder of 3. So 5k plus 1 is any multiple of 5 plus 1. 14 to the power of 5k plus 2 when divided by 11 gives a remainder of 9. 14 to the power of 5k plus 3 when divided by 11 gives a remainder of 5. 14 to the power of 5k plus 4 when divided by 11 gives a remainder of 4. And therefore 14 to the power of 143 divided by 11 can also be written as 14 to the power of 5k plus 3, because 143 when divided by 5 yields a remainder of 3. So 143 can be written as 5k plus 3. And what is the remainder when 14 to the power 5k plus 3, a number of this form, is divided by 11? The remainder is 5, which happens to be your answer. So you've seen that the pattern method of finding remainders is a very simple method to find remainders of larger powers of smaller numbers. With this, we come to an end of this session. In case you have any queries or any questions, please feel free to write to us at studentservices@pfindia.com.